Imagine walking outside on a warm summer night. You look up, expecting to see the moon, a glowing, familiar companion in our sky. But tonight, it's gone, vanished. No trace, no explanation. Just a dark, empty sky where the moon used to shine. What would happen to Earth if the moon suddenly disappeared? Let's take a journey together, not just to the moon, but deep into the fabric of how the moon shapes life on Earth. Because the moon isn't just a pretty rock in the sky. It is one of the most influential forces acting on our planet, quietly sculpting life as we know it. The moon was born out of chaos. Around 4.5 billion years ago, in the violent early days of the solar system, a Mars-sized object called Theia collided with the young Earth. The impact was so intense that molten debris from both Earth and Theia was flung into orbit. Over time, that debris came together and formed our moon. Since then, the moon has been in a gravitational dance with Earth, and it's this dance that makes so much of life here possible. If the moon were to suddenly disappear, Earth would be thrown into a kind of cosmic disarray. Let's start with the tides. The moon is the primary driver of Earth's ocean tides. Its gravitational pull creates bulges in the water, causing high tides as Earth rotates. Without the moon, tides would still exist, but they would be far weaker, driven only by the sun. Coastal ecosystems that depend on the rhythm of the tides would collapse. Species that rely on tidal breeding grounds, like horseshoe crabs, sea turtles, and certain types of fish, would be left confused and vulnerable. But it doesn't stop there. The moon acts like a stabilizer for Earth's rotation. Without it, Earth's axial tilt would become unstable. Right now, Earth tilts at about 23.5 degrees. This tilt is what gives us our seasons. But if the moon disappeared, that tilt could begin to wobble wildly over time, ranging from almost no tilt at all to as much as 85 degrees. Imagine an Earth where one day the poles face the sun directly, baking in perpetual daylight, while the equator shivers in the cold of a months-long night. Climate patterns would swing unpredictably. Crops would fail. Entire regions would shift from fertile to frozen and back again over millennia. Our day would change too. Right now, the moon's gravitational pull is slowly slowing Earth's rotation. That's why days are getting longer by about 1.7 milliseconds per century. Without the moon, that gradual slowdown would stop. In fact, Earth might begin to spin faster. Days would shorten, which could affect weather systems and the circadian rhythms of all life on Earth. And then there's the psychological impact. Throughout human history, the moon has been a constant. It's shaped mythologies, guided calendars, inspired poets, and even lit the way for night travelers. Its disappearance would leave a cultural and emotional void, a cosmic silence where a steady presence once shone. But even beyond the poetic loss, there are serious practical consequences. Space debris currently in Earth's orbit, much of which is influenced by lunar gravity, could behave unpredictably without the moon's influence. Satellite orbits could become less stable. Navigation systems that rely on lunar positioning could malfunction. The moon also serves as a shield of sorts. It absorbs or deflects some asteroids that might otherwise hit Earth. If the moon disappeared, Earth might face a higher risk of direct asteroid impacts. Small, yes, but potentially catastrophic. So let's ask, could life survive without the moon? In the short term, yes, life is resilient. Humans adapt, but over long stretches of geological time, the changes would be profound. Earth would become a more chaotic planet, less stable, less predictable. Civilization, agriculture, and weather systems would have to adjust to new and extreme variations. Now, let's consider one of the most delicate consequences: how the moon influences Earth's internal energy. The friction caused by lunar tides generates internal heat, subtly influencing geological activity like volcanic eruptions and tectonic shifts. Remove the moon, and that energy dynamic changes. We might see a decrease in plate activity, or perhaps the opposite, an unstable shift in the Earth's crust. Either way, It would alter the Earth's geology and the formation of landscapes over millions of years. And remember, the moon isn't just important to Earth. It affects our space ambitions too. Without the moon as a natural testing ground, humanity's first steps into space may have been delayed by decades. It served as our nearest laboratory for exploration, our proving ground. Without it, our journey beyond Earth might never have begun. Now all of this assumes the moon simply vanishes. What if it exploded instead? An exploding moon would shower Earth with massive fragments. Some would burn up in the atmosphere, creating dazzling meteor showers. But larger pieces could strike the surface, causing regional, if not global, devastation. Tidal shifts would happen immediately. Satellites could be knocked out. Power grids could fail. The night sky would be filled with glowing debris, beautiful, terrifying, and utterly unfamiliar. But here's the most fascinating thing. Even after all these consequences, life might find a way. New rhythms would emerge. New species might evolve to match the shorter days and unstable seasons. Humanity could adapt with new technologies, artificial lighting, climate control, geoengineering. We've adapted before. We likely would again. Still, the moon's disappearance would remind us of how finely balanced our planet is, how seemingly small celestial bodies play massive roles in our existence. The moon, hanging quietly in the sky, is often taken for granted. But without it, Earth would be less gentle, less fertile, and far more dangerous. So the next time you look up at that glowing white circle, remember, it's more than a moon. It's a guardian, a stabilizer, a partner in Earth's story. And we're lucky it's still there. Because in space, even the smallest change can change everything.